We're looking at the 1.5 video for ICA. The goal here is to use real number properties to simplify rational exponents. Now, one thing I really want to hop into real quick. Rational, great, so rational is the same thing as a fraction. I like to think of it, rational is fractional. This is something that Mr. Stevens made up. You cannot go to another classroom and be like, is that a fractional thing? No, they're going to laugh at you. All right, so rational, I call it fractional to help me remember that it's really just, a fraction, okay? It doesn't matter what the fraction is. It's just number over number, right? All right, so what happens when I have a fraction as an exponent and I want to try and simplify? Well, we kind of saw that a little bit in 1.4. Excuse me, we saw a little bit of that in 1.4. But here, I want to make sure that we know sometimes we're going to have to go forwards and sometimes we have to go backwards. So let's take a look. If I have x raised to the a over b, we know that that is the bth root of x to the a. So sometimes I'm going to have to go this direction and sometimes I might have to go back. Okay? So let's take a look at an example of what I mean by this. Let's take a look at 1,000 raised to the 1/3 power. Well, 1,000 raised to the 1/3 power is the, well, let's go from fractional exponent, right? So rational exponent. Let's go to text this into radical form. I know that I have the cube root of 1,000. And this, we already know how to simplify, right? We know that this turns into 10 times 100. This is 2 and 5. Here we get, let's go with 4 and 25, 2 and 2, 5 and 5. Right. And my index here is a 3, so I'm circling groups of 3, so I have a 2 and 2 2s here, so I have 3 2s that come out as a 2, and I have a 5, 5, 5, 5, so then I have a 5 that comes out, and I have nothing left over, so this is going to end up being 10. So that means that 1,000 raised to the 1/3 power is simply 10. Oh, sorry. Okay. Well, let's take another look at another example. Let's go with 8 raised to the negative 2/3 power. What happens if I have 8 raised to the negative 2/3 power? Well, I want to handle that negative exponent first. And remember what we saw a little bit ago, or what we saw in 1.4, right? When I have a negative exponent, it goes to the other side of the fraction and becomes positive. So I'll end up with I'll end up with 1 over 8 raised to the positive 2/3 power. That looks terrible. I'm sorry, I apologize. Let's try that again. 1 over 8 raised to the 2/3 power. Now, I can convert this to radical form. So I get 1 over the cube root of 8 squared. Well, I could go 64 here and then break it down. But I also know that whenever I have this written as the cube root of 8 squared, I could also rewrite that as the cube root of 8 squared. And now I know the cube root of 8 is 2, so this leaves me with 1 over 2 squared, and 2 squared is 4, so I'm left with 1/4. So 8 raised to the negative 2/3 power is really 1/4. And I want to explore this idea. This looks like Mr. Stevens is telling me some magic, and I don't want to do that to you. So let's take a look at this real quick. I want you to understand why I could, why can I go from here to here? Why does that work? Where I could take this exponent and all of a sudden put it on the outside, right? So the exponent started on the inside and all of a sudden it's on the outside. That's really weird. So let's explore that idea real quick. Now, I want you to remember, so recall that the square root of something times the square root of something else is the square root of those things being multiplied together, right? So I can really take a look at this. The cube root of 8 squared really is the cube root of 8 times 8, right? Right? 8 squared is the same thing as 8 times 8. Well, now I have something times something, right? Here I am. So now I'm going to go this direction. So I'm going to split this up into the cube root of 8 times the cube root of 8. And what is the meaning of something times itself? Well, the meaning of something times itself, I could rewrite that as something to the second power. So instead of the cube root of 8 times the cube root of 8, I can now look at that as the cube root of 8 squared. And that should be enough to get you through all of the homework of 1-4 and 1-5.